Hello students, in this video we are going to learn about D flip-flop. The previous video we saw about JK flip-flop and we ended by saying that a JK flip-flop is implemented by using a multiplexer together with a D flip-flop. I said that D flip-flop is going to act as a buffer. So now what is a buffer? Whatever data is there in the input side will be in the output. Whatever data is there in the input will be in your output. So D flip-flop is made by using two D latches. Is made using two D latches and it is going to act as a buffer. What is a D latch? D is the input and Q is the output. What is EN? It is an enable pin. When my enable pin is high, whatever data is there in your D will be at the output Q. Q is equal to D. If my enable pin is 0, Q will not change. It will be holding the previous value. How to implement a D flip-flop? Directly cascade two D latches. But one more thing that we must understand is the enable pins that we are having must be inverted. So for the first enable signal, we are going to give the clock, and for the second enable pin, we are going to give the inverted clock. So D1 will be passed at the output of Q1 and that will be passed as the input of D2 and output 2 will be equal to output 1 where output 1 is nothing but your D1. So at the output, you will be getting the input D1. So it is nothing but your D flip-flop. What is this? Data flip-flop or delayed flip-flop. Now, first you must know how to implement a latch using a transmission gate and then combine two latches, you will be getting a final output. So how to implement the D latch using gate level implementation. What is this? It is nothing but your SR latch. If you observe clearly, it is nothing but an SR latch, but there was a condition for the same inputs. We mentioned it as is not allowed. To avoid that, we are giving an inverted input. So both my inputs will not be same at the same time. So my D is the input that is being given to an inverter and it is given to two inputs. Now, this is the operation and what is my output? See, if my enable input is 0, if my enable input is 0, there is no operation. If my enable input is 0, there is no operation. And then, what is the next one? If my enable is 1, my circuit is enabled. So whatever data I am giving in my input will be at the output. Whatever input I am giving will be at the output. If I give D is equal to 0, my output Qn plus 1 will be equal to 0. If I give D is equal to 1, whatever data is there, it is 1. So output Q will be equal to 1. Right? Now see, I'm implementing this logic by using a transmission gate. See the top, an enable pin is given. So a transmission gate has been taken. Now, if my enable pin is 1, my data has to pass. What will be in the output? Q. I said there will be an output node that will be having a capacitor. It will store the data only for some time. After that, it will start to leak. So your data may change. So for avoiding that, this Q is sent into a static inverter, right? So we are getting Q bar. We want only Q. Just to avoid the leakage condition, we connected an inverter. So what we can connect again? Again another inverter to make it again as Q, right? These two inverters were added just to make sure that output is not leaked. Again, this Q and again this Q is there, the boxed one. Both the Qs can be connected, but to provide a control, I am adding another transmission gate and that is having enable pins and that is the opposite version of the main transmission gate. See, now here enable pin is EN and here I am giving the opposite, it is inverted enable pin. Again here it is enable bar and here it is enable. This is the D latch using transmission gate. How to make a D flip-flop using this? To make a D flip-flop, we have to combine two D latches. Combine these two. But think what we learned here. See, if you want to combine two D latches, we will be giving the clock one direct clock and one more is inverted clock. So here one I am giving a direct clock and one more I am giving inverted clock. How I am saying? One, see, this is clock and clock bar for the first NAND gate, first transmission gate. And for the second, the clock is inverted. So wherever clock is there, I am giving clock bar, and wherever clock bar is there, I am giving as clock. Wherever clock bar is there, again clock, and for clock, I am giving clock bar. Just combine both, you will be getting the output D. But we must know how this is working as a D flip-flop, right? What I said, D flip-flop, your output will be the input D if my clock or enable is there. See the working case. When my clock is equal to 1 and my clock bar is equal to 0, right? When my clock is equal to 1, what are the transmission gate is on? You just draw the diagram on your note and just see the working. When my clock is equal to 1, what will happen? The first transmission gate and the fourth transmission gate will be on. What is it? My first transmission gate and fourth transmission gate are on, whereas second and third transmission gate are off. If my first transmission gate is on, what is Q1? Q1 is nothing but D1. So what is the output of the first inverter? Just Q1 bar, right? And now TG4 is also on. What is TG4? Which is transmission gate 4. It is also on. So what is Q2 holding? Q2, T3 is off, right? See, first one is on and fourth one is on, whereas this 2 and 3 is off. So as third transmission gate is cut off, there is just a loop and that is looping or holding the previous value. So Q2 is just holding the previous value. Now, I'm giving my clock is equal to 0. If my clock is equal to 0, clock bar will be equal to 1. So what is happening? Clock is equal to 0. If I give clock is equal to 0, what will happen to my first transmission gate? 0 to an NMOS will cut off. So you can easily say there is no input being accepted. But what is happening in the remaining part of the circuit? So clock is now 0. So where is the clock? Again in T4, the clock is again 0. So this transmission gate is also off. So two transmission gate that is on the second phase is second transmission gate and third transmission gate. So previously Q1 would have stored some value. That value is sent at the output of the inverter, which is Q1 bar, and this Q1 bar will be there, and Q1 bar is the input of third transmission gate. And what is the output of the second inverter? It will be Q1. What is Q1? Which is nothing but your D. See now again, first transmission gate is off. The circuit is cut off. But previously, the first inverter's input is Q1. So this Q1 is inverted and it is given to Q1 bar. And now it is Q1 bar, and this Q1 bar is the input to the third transmission gate. It is working. It is giving to second inverter. What will be the output of again the second inverter? It will be Q1. What is Q1? It is nothing but your D. So what is at the output? Whatever data we are giving in the input is being occurring in your output when I make my clock is equal to 0. So this is how my data flip-flop or D flip-flop is working. So in next video, we shall see about shift register. Thank you.